Hello everyone. Today's objectives is using substitution to solve a system of equations. So let's go through the three methods of solving system. We've done the graphing. We are going to talk about the substitution today. And then we have one more, it's called the elimination, and that will be introduced tomorrow. So to start off, to solve a system of equation in two variables, we are trying to find an x coordinates and a y coordinates that makes both equations true. This means the x value in one equation must be the same as the x value in the other equation. This gives us another way to solve a system of equation using the substitution method. Okay? That's the substitution idea. The procedure, just in case you guys don't remember, the procedure is solving systems of two linear equations using substitution is 1. Isolate one of the variables in one of the equation. 2. In the other equation, substitute the expression you find in step 1 for that variable. 3. Solve this new equation. It will now only be one variable, so it should not be x and y, it should be either just x or either just the y. 4. Using one of the equations containing both variables, substitute the value you find in step 3 for that variable, and solve for value of the other variables. 5. Checking the solutions. 5. Check the solution in the original equation. Okay, let's start with example number 1. Now, example number 1 is very nice. The example number 1 already have the y by itself. That's the way we want to have it, either y or x by itself. Since y is already by itself, we are going to take this 13 minus 4x, plug into the y position, and we're going to replace it. So in this case, it's going to be negative 2x plus 3 times the y, and y in this case is the 13 minus 4x. And then that's going to equal to, finish the whole thing, equals negative. Then that is negative 2x plus 3, parenthesis 13 minus 4x, parenthesis equals negative 17. All right, and then I'm going to pause the video. You guys should be able to solve that. After I solve it, x equals 4. That's the first step. Then we're going to plug into an equation. Doesn't matter which one. It could be the first one or the second one that I was giving it to you. But in this case, I will probably put it in the first one just because y is already by itself. I don't have to solve it. I just have to plug in to the x. So y in this case is going to equal to x equals 4, 13 minus 4 times 4, because x equals 4. Then you just have to solve it. So 13 minus 16, that's going to be negative 3. Now, the very important thing is you got to make sure this gets put back into our order pair, because that's how the proper way to write your answer. So it should be 4 for x, negative 3 for your y. So that will be your intersection, and that will be the solution for this system. Example number 2. A little different than example number 1. The reason for that is example number 2 does not have x or y by itself. Now you can probably pick the letter the way you will pick the letter is because I will pick it with no number in front of it. Alright? Now, since both x and negative y don't have any number in front of it, the one I will probably pick will be x, because then I don't have to deal with the negative sign. So because of that, I'm going to say change the x plus 3y equals 9 into just x by itself. So that is going to become x plus 3y equals 9. And then you're going to just minus 3y on both sides. I'm getting x by itself. So x is going to equal to 9 minus 3y. Alright, so now we know x equals 9 equals 3y. What we're going to do is we are going to plug in the second equation. If you use the first one, change the form, you cannot plug into the first one. You have to plug into the other one. So that's going to be 2. X is going to be 9 minus 3y minus y equals negative 10. Now we are back into one variables again. That would be 18 minus 6y minus y equals negative 10. And then of course you have to combine like term, and that's going to be 18 minus 7y equals negative 10. And minus 18 on both sides, negative 7y equals negative 28. And then you should see y equals 4. And then you need to just plug it in. Now since we already have something that says x equals 9 minus 3y, I'm going to plug it into that one just because it will make it easier. You can plug into x plus 3y equals 9 or 2x minus y equals negative 10. All of them should give you the same exact number. So let's plug in the ones that's easier, which is this one. And that's going to be x is equal to 9 minus 3 times 4. And that's going to be 9 minus 12, and that is going to be negative 3. So your order pair for this one is going to be negative 3, comma 4. So let's check the answer. For example number 3, when you plug in your x, I move the x around, so I got x equals negative 4 plus 4y. Into the second equation, I got 0 equals 36, and you know that 0 does not equal to 36. So therefore, it's going to be no solution, parallel lines, and they are inconsistent. That's a I think that will be a different vocabulary for you. So inconsistent means that they are not going to have any solution. For example, that's number 3. Number 4, what you have here is you have x already by itself, so you're going to plug in from the second equation to the first equation. Notice the orange line I pointed out. Once you plug it in, you simplify, you got 12 equals 12. And they are exactly the same. And because they are exactly the same, they have infinite many solutions. Same line, consistent, dependent. I also want to show you guys, and I want to make a point of it, is to write the answer. It should be all order pairs along the equation. You can pick one. You can pick 3x minus 6y equals 12. And that is very important because it's not just anywhere. It's just that line will be the solution. Not any line. That is the only line. Okay, 3x minus 6y equals 12 is the only line for the solution. And that concludes today's notes. And thank you so much for watching.